Hello everyone, my name is David, and my teammates are Angela, Hema, and Ruchika. In this video, I will be demonstrating our project, which was developing a memory ballooning device for the OpenBSD operating system's hypervisor. Recall that a virtual machine is a software implementation of a computer which provides the same functionality as a physical computer. A hypervisor is a host to the guest virtual machines, providing them with their underlying hardware and computing resources. Each guest uses up a portion of the hypervisor's memory. Once the memory has been given out, the hypervisor normally has no way to get it back, which can result in the hypervisor running out of memory for itself. This is where the memory ballooning concept comes in. We implemented a new device for the hypervisor, which communicates with some driver software on each guest and asks for some unused memory to be returned. If any of the guests have unused memory, a virtual balloon expands in the guest, which means the host can now use that memory for itself. After the low memory condition passes, the guest balloons deflate and their memory is returned to them. The memory balloon concept in OpenBSD enables the hypervisor to maximize its limited memory resources to support multiple guest virtual machines by dynamically reallocating memory as needed between the guest and hypervisor. This balloon can be operated automatically or manually. For this demonstration, I will be manually inflating and deflating the balloon. On my screen, you see three windows. The window on the left is a console for a VM running OpenBSD. This VM is called Outer because it is at the first level of virtualization. It is running our custom kernel, which implements our device. The two terminals on the right are SSH'd into the console. In order to verify that the balloon is operating correctly, I will need to enable debugging messages to be printed by VMD, which is a virtual machine daemon. I will end the process and restart VMD with a debugging option turned on. This window is showing the output from VMD. Now I will use vmctl, which is a virtual machine controller, to start a new VM. This VM will be running inside of the outer VM, so I will call it inner. The window on the left now shows the console for inner. At the boot prompt, I enter BSD0 because I am choosing to run inner using our custom kernel that implements our new device. As the inner VM boots up, several devices will be presented to the VM from the hypervisor. One of these devices is our CumRNet VirtIO memory balloon device. Then you will see the first communication between the memory balloon driver and the memory balloon device. VIOMB VirtIO memory balloon is the driver, and VIOMBH VirtIO memory balloon hypervisor is the device. A worker function in the driver establishes a communications mechanism called a stats queue for sending memory statistics to the device. The inner VM has loaded and I can log in. I can use the bottom right terminal to display the status of the VMs running in outer. As you can see, there is the inner VM. Before outer attempts to inflate inner balloon, it needs to know the current memory status of inner so that it doesn't request more than inner can supply. I will use vmctl to send a stats command to outer in order to collect memory statistics. You can see that inner's worker has produced 6 memory statistics results. These same values are also reflected in VMD's debugging statements from VIOMBH. After outer knows the memory of each VM, it may use an optimized algorithm to determine how many pages to collect from each VM. I will use vmctl to send a balloon inflation command to outer. This command will cause outer to direct inner to inflate its memory balloon to a size of 8192 bytes. A page in memory is 4096 bytes or 4 kilobytes, so this request is for 2 pages. Inner shows inflate 0 out of 2, meaning it has inflated 0 out of 2 pages. It frees pages until it has freed the 2 required pages. Notice how the 2 memory addresses in inner are the same that VMD shows. Inner has successfully returned 2 pages to the hypervisor. Now I will use vmctl to send a balloon deflation command to outer. This command will cause outer to direct inner to deflate its memory balloon. No size needs to be given, so inner will deflate its balloon completely. You can see in inner that it has deflated its balloon from a size of 2 down to 0. The inner VM now has access to all of its original memory. And that is how memory ballooning works in OpenBSD. Thanks for viewing our presentation.